What we got here? Check this out. Okay. Switch the room corp over to 120. Run a series through the coil and through a capacitor in series, and there's another capacitor in parallel. So effectively, 10 microfarads of capacitance in series, pulsing this MOT transformer. Now, this is actually just running AC. I have this there to try DC, but it's on AC right now. Anyway, wasn't enough amperage to trigger the room corp because I need more capacitance, it seems, for the reactance. So instead, I took the terminals of the vibrator pin and ran them to the rotary. So the rotary is actually chopping the 120 volts AC into the MOT. Output of the MOT is going into this capacitor bank here, the high voltage condensers, through the primary coil, and then there's a spark gap there. Just a second. Okay. Got the kilowatt meter plugged in here. And as you see, it's fluctuating anywhere from 2 to 6 watts. Okay. When the rotary chops it, there seems to be an effect of a small amperage being pulled forward, which is what we see in the wattage. Like if I actually flip over to amperage, you'll see that's volt amps. Amps. Okay, 0.18 amps. There's a light point, so it's all over the place with the amperage. The same as it is with the wattage. But the interesting thing is that because this chop is pulling a little bit forward, there's a disrupted AC effect going on that appears to be pushing backwards at a greater pressure, a greater amount of current going backwards. As you see, this has been running, watch this now, this has been running for 3 hours and 25 minutes, okay? Two to 6 watts approximately appear to be what's powering these. We got 3 CFL bulbs, an LED bulb, a 4-foot black light in the middle there, and this 4-foot fluorescent light here. And as you can see, the secondary as well can even light up this bulb pretty good. And even when I short the secondary, it doesn't stop the oscillations coming from the primary, because it's still, you know, whatever 2,000-3,000 volts coming out of this MOT going through the primary. So there's still enough radiation to light that bulb, to light all these bulbs from the primary side rather than the secondary side. But as you can see, the secondary is arcing not very far, maybe a half of an inch. I can back this gap out and get it to snap a little harder for the secondary, and that will allow me to get a little bit more voltage out of there. But that's not what I'm after right now. The interesting thing is that while this has been running for the past 3.5 hours and doing this kilowatt meter has been fluctuating 2 to 6 watts apparently. And now we look at the kilowatt reading here. This is the timer, so 3 hours and 27 minutes. The total consumption now of this 2 to 6 watts fluctuation during this 3.5 hours is 0. If only this meter could read what was going backwards into this circuit. Very interesting.